Can you see my screen?
Yep, good.
Okay. Vanakkam, I am Shanthi. I am excited to take a session on TypeScript. This will cover all the basics with code examples. So let's dive in. So why TypeScript came into being? So it's the first thing. So in 1995, JavaScript was invented, and it was designed as a small scripting language for simple web pages and browsers. And around 1999, JavaScript was capable of supporting dynamic web pages, and that became a common practice around 2005. Since it started as a small scripting language, JavaScript was designed to be very flexible and easy to use for small applications. These features make JavaScript a great first language to learn, but they also make it less than ideal for building larger scale applications. So stricter programming languages will inform the developer when they change one area of code in a way that will break other areas. Since JavaScript will not warn, this may lead to unexpected behavior at runtime. So Microsoft developed TypeScript, which was released publicly in 2012. The idea was to blend the flexibility of JavaScript with the advantages of a stricter language. So what is TypeScript? TypeScript is a programming language that adds types to JavaScript. So it allows you to write JavaScript with a set of tools called a type system that can spot potential bugs and clarify the structure of the code and also help refactor it. In addition to that, TypeScripts added newer JavaScript language features such as arrow functions and classes years before they were added to JavaScript officially. Basically, you can see TypeScript code is a superset of JavaScript code. It has all the features of traditional JavaScript, but has some new features too. So as per the developer survey results in Stack Overflow, TypeScript is one of the most loved languages in the world. It's number 3, and with respect to what language a developer wants to work on, it is the second language. It is used by open source projects such as Angular and Webpack, and also in large scale development at Amazon and Google. So now let's get to how to use TypeScript. So TypeScript is having the extension .ts. So ideally we would first create a .ts file, and then in the command line you just say npm init -y. That would create a node project, and then you say npm I in TypeScript, npm install TypeScript. That will install TypeScript. Then we can use the transpiler. So I'll just quickly show you in Replit. This basically just I'm creating a new file .ts. So I'll just console log. Yes. And then I'm just going to do an npx tsc new file.ts. So this takes a little bit of time. So initially I thought I would show everything as live code, but since this is taking too much of time, I have put all the code in the PPT itself, so in the presentation itself. So yeah, so now you see when it is run this transpiler, it creates a new file.js just in the same file name with a JavaScript extension, which will also have the same content. The difference is that whatever types that are mentioned in TypeScript, those will be removed when this JavaScript is getting created. So now, in order to run, we just say the JavaScript file, and it will just print this is Java in TypeScript. So that's how we run a TypeScript code. So another thing that I wanted to say is about the config.ts. So if you see here, we can define a configuration file tsconfig.json, which has a compiler options as an object in which you have the target, which is defined as ES 2017, which means it's it is taking the ECMAScript 2017, and it uses CommonJS as the module. And there are several conditions which you can make the TypeScript as strict as possible or as lenient as possible. So typically, this will list all the possible ways that you can control the TypeScript in terms of options. So I have just modified it just to say strict null checks alone. Like if there is any variable that is defined, which is not defined as null, but it is returning a null value, then it will throw an error. So that's what this is. And this include basically says that I need to compile whatever is with the .ts extension. So if I just type here npx tsc alone, it will basically transpile all the TypeScript files it sees here. So now we're going to see about type shape. Say we give a string with a method which is slightly incorrect. Say, for example, you all know that a string .to uppercase is supposed to make it uppercase. Now I have made purposefully an error in the case. I have not put it as capital C, but small c. So in a case of TypeScript, it will clearly ask me, did you mean to uppercase? So which is a very convenient message for me to realize that I have made a typo error. Whereas in JavaScript, it will just say, this .to uppercase is not a function. So this is because a TypeScript knows what types our objects are. It also knows what shapes our objects are there too. So an object shape describes, among other things, what properties and methods it does or doesn't contain. The built-in types in JavaScript each have known properties and methods that always exist. Like all strings, for example, are known to have a .length property and .to lowercase and so on. So many other methods. So a TypeScript would automatically know that these are existing. So if you make a mistake, a typo error, it will suggest that particular property or method. And JavaScript allows us to assign any value to any variable. So it makes it very flexible to use, which can be good for getting started, quickly coding. But in practice, variables that are assigned values of multiple types throughout a program can be very confusing or even lead to bugs. So one of the first things we'll discover with TypeScript is that when we declare a variable with an initial value, the variable can never be reassigned a value of a different data type. So this is an example of type inference. In this example, answer is initialized with the number 42. So the compiler assumes the type of the variable answer to be a number. So when we try to assign a string value, say answer to the ultimate question of life, the universe and everything, it throws an error that string is not assignable to type number. If you see in the second example, when a variable is declared without being assigned an initial value, just as let answer, then TypeScript will not be able to infer its type. So where it is not able to infer a type, TypeScript will consider the variable to be of type any. Variables of type any can be assigned to any value, and TypeScript won't give an error if they are reassigned to a different type later on. Like in this example, this won't give the second example would not give any error. So in a case, we don't want to assign an initial value, but we don't want TypeScript to be of any type also, because then it won't be able to protect us from mistakenly assigning a variable to an incorrect type. So how do we specify the compiler? This variable is of this type. We can do this by using a type annotation, also known as type declaration. We provide a type annotation by appending a variable with a colon and the type, example, number, string, or any. As we saw earlier, any is a default value and a default type when no type is mentioned. Though type annotations may make the code wordy, they get automatically removed when compiled with JavaScript, as I said. We are going to see what happens when we compare varied types, say a string and a number. JavaScript allows comparing a string and a number. It does not throw any error, which can also lead to unexpected behavior. Whereas TypeScript will throw an error that you cannot use the greater than operator to type string and number. As you can see in this example, restaurant's distance is 5 kilometers, that is, which is 5 or 8 kilometers, which is a string value. Whereas max distance is a number. So the comparison throws a compilation error that, you cannot assign the greater than operators, it's between the type string and number. In JavaScript, when parameters are of wrong type or wrong order, no error is thrown. It simply returns undefined. Say, for example, in this case, print text length is passing a 3, which is a number, but it takes only a string as the parameter. So it will just say argument of type number is not assignable to parameter of type string when we do this in TypeScript. So this is basically, it catches the bug early on. When a parameter is not passed for an argument of a function, TypeScript throws an error. Like in this first example, the greet function specifies an argument name, but that parameter is not provided while calling the function greet. So TypeScript complains with an error that I'm expecting one argument. Now what we want is the code to execute the string value guessed when a parameter is not provided. So how do we tell that to TypeScript? We can specify it by saying this is an optional parameter with a simple question mark next to the variable. Also remember, we need to tell how to handle when the value for the variable is not provided. In this case, we are providing an OR operator and specifying the string guessed to be used when the value is not available for that variable. So when we call the function without a parameter, it prints the string guessed. Another way to do this by defining a default value to the parameter. If a parameter is assigned a default value, TypeScript will infer the variable type to be the same as the default values type. Parameters with default values don't need a question mark after their name, because assigning a default value already implies that they are optional parameters. TypeScript can also infer return types. So in this example, we are converting Celsius to Fahrenheit. The variable temperature is expecting a return value of number from the function, and so its type is declared as number. But then when I'm returning the function, I'm overzealously mentioning that it is a Fahrenheit and returning it as a string. So though I did not mention the return type to be string in the function definition, TypeScript sees the return value and infers its type to be string, and hence throws the error, type string is not assignable to type number. So this is basically inferring the return types. So can you identify why this error is occurring? So what happens here is that we are trying to return two different types, but we specified the return type as string. So it throws an error type undefined is not assignable to type string. Suppose we don't want to return anything in a function, we must treat the return type as void. You can explicitly mention here instead of string as void. So so far, is it clear or any questions? I'm just moving forward, assuming that you're understanding.
So far, it's very clear. Thanks.
Okay. So when we are defining a function, it is best practice to document about it. You would have seen a single line comment and a multi-line comment. There is a third kind. It is a documentation comment. Documentation comment is available as part of the standard TypeScript. So even in JavaScript, it is not part of standard JavaScript, but it is available in JSDoc. So here we have come to array. So here there is an array of movies. We want to ensure to allow only strings in the array and not allow any other type. So in JavaScript, you would need to use, say if we want to only allow strings, how we would implement in JavaScript is that we would use a type of operator and compare the parameters to string, and after that allow the push into the array. But still this can be overridden by providing a value by accessing the index of the array, like here, like this example here, movies array of 6 equal to 100. This would allow this number to be assigned to the string array. So whereas in TypeScript, since we assigned an initial value here of an array of strings, it will infer this array to be of type strings. And it will throw an error, type number is not assignable to string when we try to do the same approach here, like movies array of 6 equal to 10. It will throw an error at that time when we're trying to access. So this is type safe in TypeScript. So explicit array type annotation is it's simple. Just need to provide the type along with square brackets. So here we see examples of string array, Boolean array, and number array. Another way to type annotation is array of string, like I shown here. And here's an example of multi-dimension array, which takes in the other arrays as value. For example, best breakfast and best lunch are themselves arrays, but they are a part of best meal. 1 minute. Yeah. As we know, JavaScript arrays are flexible and can have elements of different types. So with TypeScript also, we want to have arrays with different types. So, but in TypeScript, it has to be a fixed sequence of types. So when an array is typed with elements of specific types, it's called a tuple. Tuple types specify both the lengths and the order of compatible tuples. And it will cause an error if either of these conditions are not met. So in the first example here, the tuple is specified as 2 numbers, but is initialized with 3 numbers. So it will throw an error. The tuple should only have 2 elements. The second example to show the necessity of the order. Here we are specifying the type of the tuple to contain a number, string, and a Boolean in the set order. But the value assigned is of a different order, string, number, Boolean. So it throws an error stating what type each element should be. Like you will access an array element, we can access or change the tuple element by using an index, like a square bracket and an index. But still, tuples and arrays do not have compatible types within TypeScript. Say, this would throw an error. tuple is equal to array, where you're assigning an array to a tuple. Even when the elements are of the correct type and correct order, it doesn't matter. Still, you cannot assign an array to a tuple. So in the code here, TypeScript infers the variable concat result as an array of numbers and not a tuple. So the takeaway here is that type inference returns arrays. So if you want it to be a tuple, you need to explicitly annotate the type to the type annotation. So in this example, you see that the second parameter is an array and it is specified with 3 dots. This is the rest parameter. The rest parameter syntax allows a function to accept an indefinite number of arguments as an array. So it provides a way to represent variadic functions in JavaScript. Variadic means one which accepts a variable number of arguments. So in this example, it basically takes up the array of string and concatenates it, and you print that output together. So it will print, say, hashtag save soil as well. So we'll see a usage of spread syntax. So tuple helps in the function call for spread syntax. So here we see a policy and we have the parameters of name and age, and child is minor, and I'm sorry, child is Boolean, and we're basically printing this with this. This is called as the spread syntax. So the dot 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 and this child, it basically spreads this and value into it as in a parameter, and it is able to execute it. There are many situations when we might want to limit the possible values of a variable. So for this, we can use a complex type called enum. We use enums when we would like to enumerate all the possible values that a variable could have. This is in contrast to most of the other types we have studied. A variable of string type can have any string as a value. There are infinitely many possible strings, and it would be impossible to list them all. So, but enum has only a specific set of values. In this example, we have a specific set of drink names, like in a menu. So to access these values, we need to say the enum variable name drink, and then dot the value, say drink dot panagam. So that's how we access the enum value. Suppose you give a different value which is not there in the enum collection. Like in this example, drink.spicy buttermilk, it will throw a type error, like property spicy buttermilk does not exist on type of drink. Also, if you mention the enum value directly, like fruit juice here, this will again throw a type error. You cannot find name fruit juice because it cannot recognize this fruit juice as a variable. It can only understand if you provide the enum variable name. Interestingly, if you assign a number, it will throw no errors. That's because TypeScript processes these kinds of enum types using numbers. Enum values are assigned to a numerical value according to their listed order. Say, for example, Panagam will take 0, and the next one will take lemonade takes 1, and buttermilk takes 2, and fruit juice takes 3. This is automatically done by TypeScript. So when we say 1 in this example, it would indicate the lemonade. It is also possible to change the numeric order by assigning a particular numeric value. Example, you can say panagam is equal to 3, then it will take automatically lemonade as 4 and buttermilk as 5 and fruit juice is 6. And we can also specify different numbers for this, each one of them, like for example, panagam is equal to 5 or lemonade equal to 21. Random numbers for each of them can also be assigned. So what we essentially saw earlier are called numeric enums, since they are based on numbers. I've just listed them in the left side for easy comparison. With numeric enums, the numbers could be assigned automatically like 0, 1, 2, etc. But with string enums, we must explicitly write the string value. Technically, any string will do. Say, for example, in the string enum, Jonas, I have specified Carnatic as an enum, and I have put it in all capitals of the same variable name. So similar. So this is the convention that is followed. But it wouldn't hurt if you put not all uppercase in a normal way, or even if you completely give a different value also, it wouldn't have a problem. So basically we follow this capital convention so that error messages and logs will be much more informative on what it is. So the same as like in a numeric enum, you cannot specify it like some random value. You cannot specify it just with the Carnatic as just the value. You need to say it as Jonas dot Carnatic. That is the only allowed thing. So string enum is more strict because you cannot assign a number to it. So while having a string number is better, a string enum is better than a numeric enum, is that because it's just more informative to see in the logs and so on. So TypeScript object types are the most common custom types. So similar to how a variable name is defined, we annotate with colon and the type. So let's see this example. A person is defined as an object which has two keys, name and age, with a type string and number respectively. In the next step, we assign a value to the name key as Agastya. But if you notice, the key years old is defined, the value of 4,000. So, but this years old should be age. So it will throw an error, no age property. In the next step, we are assigning the age as wouldn't you like to know for Markandeya, which is a wrong type as it expects number, but we gave a string. So it will throw an error, age property has the wrong type. Next is an example of an object family, which has a custom type gender assigned to the key gender. The custom type gender is defined as an enum. So we can notice that adults and children are having the type as an array of the same object, type, name, and age with type string and number. So this is a repetition. So how do we avoid this repetition? So for that, we can use type alias. Type alias is a convenient way to provide an alternative name, a type name, and refer it. So type alias is to customize the types in our programs. They're truly useful for referring complicated types that needs to be repeated, like example, object types and tuples types and so on. So this, when there's needless repetition, it comes very handy. But you have to understand TypeScript aliases are nothing more than names. They have absolutely no influence over how types work. They are not distinct types. Say in this case, I can use a different object type, say user, and define it the same and reuse it in the place of person, and there would be no conflict. They'll just be alternative names for the same thing. So far, so good. I can continue. Any questions so far? Okay. So we know that in JavaScript, functions can be assigned to variables. In TypeScript also, we can precisely control the kinds of functions assignable to a variable by specifying the argument type and the return type also. So here I have created a type operation for conducting mathematical operations. I am calling the functions of multiply and subtract as callback functions with the type operation. This ensures if the passed on function doesn't match the parameters of number, it will throw an error. So in this example, instead of defining the types for each function, we are setting the function type and ensuring the type check for the function. There's one thing to note here. We must not omit the parameters, parameter names, or this parenthesis basically. You should not omit this parenthesis, and you should not omit the parameter names. Because it will, I mean, it will still throw an error. It will prompt saying that parameter has a name but no type. And then did you mean, say for example, if I just provided here just the number, it will say, did you mean arg1 colon number? It'll ask you it'll throw one type error saying that. I mean, it'll basically show it when you're typing it itself. When you're typing it in Visual Studio Code itself, it will say, did you mean, there'll be a small dot here, and then it'll say, did you mean to type arg1 colon string or something like that. So if I just gave here string alone. So if I miss the parenthesis, then it would say semicolon expected, because it will think you're defining the type of a variable. So it is important to define the parenthesis as well as the type for each and every parameter with a name. TypeScript provides a special way to create collections of types that share similarities, like certain similarities, like in this case. So these are called generic types. Generic types gives us the power to define our own collections of object types. These collections are parameterized by one or more type variables. So how do we write a generic type? Is we say type name, and then within an angular brackets T, which allows us to use T within the type annotation as a type placeholder. So later when the generic type is used, T is replaced with the provided type. Writing T is just a convention. We could just as easily use any variable name like yes or generic type or anything that you want. It's just convention to use T. So in this example, we are defining a generic type family which has a T as the type. The parents and children are defined as an array of type T. In the next step, we are defining what type the placeholder T should take in. In the case of A family, it is of type human. So the parents and the children take the value of an array of type human. Whereas B family is defined as a type of the family of type dog. So the parents and children take the values of an array of type dog. So we can notice that the same generic type family of T can be used to create objects of family of dog and human. Though human type has age as a property and dog has is pet as a Boolean as a property. So that's where generic types are useful. Just like how we saw in generic types, in generic functions, we have defined it as like function name of T within angular brackets. This allows us to use T within the type annotation as a type placeholder. Later, when the function is invoked, T is replaced with the provided type. So let's see this example. We have a generic function get array, and whatever items is passed as parameters, we need to concat the items. So in the case of mynum array and mynum arr, it will just create an array of the passed numbers array, and it will only allow numbers to the mynum array. So when we do a push mynum array, it will contain 100, 200, 300, and 420. And my strr will contain non-violence is the greatest virtue, and it will also contain ahimsa paramo dharma in the same array. Whereas when we try to add a string to a number array or vice versa, this will both throw an error.
TypeScript.
Type error.
Oh, I use that every day.
Yeah.
It's amazing.
I'm sorry, did someone speak anything? Okay. I think it's not to me. So one thing you need to note is that we don't use the keyword type for generic functions. We just say function, and we just declare it, define it that way. TypeScript lets us type variables with different levels of type specificity. If we declare a variable with a specific type, say as a number, TypeScript will only allow the variable to have a numeric value. On the other end of the specificity spectrum, we could type a variable as any. But any type is very unspecific. So TypeScript will allow a value of any type to be assigned without complaining and throwing an error. Sometimes we need to strike a balance between extreme specificity and being totally unspecific with our types. So imagine we have to accommodate a client ID or a phone number, which is both string as well as number type. If we specify it as any, then even Boolean value will be allowed, which we don't want. So to solve this problem, TypeScript allows us to be flexible with how specific our types are by combining different types. When we combine types, it is called a union. We can combine two types with a vertical bar character. This is the syntax for defining a union. So string and then the vertical character, or vertical bar character, and then number. This is the way to define a union. So each type in a union is called a type member. One of the awesome things about TypeScript is that it's able to infer types in many cases so that we don't have to manually write them. A great example is a function's return type. TypeScript will look at the contents of a function and infer which types the function can return. If there are multiple possible return types, TypeScript will infer the return type as a union. Since TypeScript can infer the function's return type, there's no need for us to manually define it. So for this case, this Jedi example, in this function create Jedi, we have not specified any return type, but still it will infer the type as the union type of Jedi or string. Because this is a string and that's a return, this is a Jedi. So it will infer that it is the union of this type. And Now, what if we want to specify an array which has more than one type? An example, if we had a list of dates in both types, we would need an array that allows both string and number values. To create a union that supports multiple types for an array's values, wrap the union in parentheses, string or number, and then use the array notation. The parentheses here are vitally important in order to type the arrays correctly. Suppose we left this parameter and we define it like this, string of number and just this, then it would understand it to allow, the TypeScript would understand that we need to allow either a string or an array of numbers. So that's why this parenthesis is very important. So basically we can use unions to allow arrays to have multiple types of values. So far we saw the type members of union to be of primitive type. We can also provide a specific value as a type member. Those are called literal types. So literal type unions are useful when we want to create distinct states within a program. So I've just given you an example of a weekday here. And it can only take up these specific literals that is mentioned here. Weekday can only take those values. It cannot take any other string. If any other string is mentioned, it will TypeScript will throw an error. So this technique allows us to write functions that are specific about the states that we can handle. So which means it helps us write code that's less prone to errors. When we put type members in a union, TypeScript will only allow us to use the common methods and properties that all members of the union share. This is also applicable to type objects. Say we have a variable type charge, which is a union of Boolean or number. Then when we use a method .toString, it will work because the method .toString is applicable to both Boolean and number. Whereas when we use a method, say toFixed, it is specific to a number. So it will throw an error as the value may be a Boolean type 2. So it wouldn't accept this. It will throw an error. So to call a method or property on a variable typed as a union, we can only call methods or properties that are identical on all members of the union. But this is not so convenient because we would need to do something specific when it is of a particular type. So how nice it would be TypeScript can, if TypeScript can provide, understand our intentions that we want to use this particular type at this particular code. So that is where type narrowing comes in. Type narrowing is when TypeScript can figure out what type a variable can be at a given point in our code. That is, it can infer more specific types based on the variables surrounding code. In our example, TypeScript has narrowed the type using a type guard to only be a string. Type guard is basically the if type of value equal to string. So that's called a type guard. Type narrowing allows us to use unions, then perform type specific logic. So TypeScript can recognize type of type guards that checks for these specific values, say string, number, Boolean, and symbol. In this example, we have created a function format content. It can take either a string or a number. If it is a string value, it should change it to lowercase. If it is a numeric value, then it should add decimals to the number. So this will work properly because of the type guard. So whatever code we need to write, which is common for all the types mentioned in the union, we can write it outside, like here. like I have written, the comment ID can be a number of string. This is the part where we write the common code for both string as well as the other type. But if it is type specific, we need to call some method or do some functionality, then we use the type guard and write the specific instructions here. So with this type narrowing, we can narrow down what methods and properties are available for that variable. So the whole concept of allowing us to type a variable as a union, then narrow down the union with the type guard to call type member specific methods or properties, that is called type narrowing. Sometimes we may not be informed of all the methods in a type. So what if we want to see if a specific method exists on a type? So that's where the in operator comes into play. The in operator checks if a property exists on an object. So in is especially helpful when we have data represented as objects. So let's see this example. We have an object type vocal, which has a variable genre and a method sing, and another object type we have is instrumental, which has a variable instrument and a method play. Now let's create two objects. One is singer, that is implicitly of the type vocal, and the other is Vainika, which is implicitly of the type instrumental. Now we are creating a function, concert, which can be of type vocal or instrumental. We don't know what type of variable we will be passing in the function call. So we will have to check whether the method sing is in the variable, that's part, and then only we have to call the method sing. Similarly, we check for play in perform, and then we call the method play. So this is how we use in operator as a type guard. So first we saw a type of, now second we are seeing the in operator as a type guard for type. So in this example, we've used two separate if statements as type guards to handle each possible type. So how can we simplify this? Anyone? Okay.
Can you do a ternary operator with it?
No, it's a simple thing. If, then else.
Okay.
No? Else.
Oh, okay.
So use an else statement. So it turns out that TypeScript can recognize the else block of an if else statement also. So as being the, so when you say something inside else, it will take it as being the opposite type guard check of the if statement automatically. So TypeScript can type narrow after a type guard with an else block. So basically TypeScript understands that else block of an if statement must be the inverse condition of the if statement's conditional. So in this example, we have typed two types. We have defined two types, dosa and pongal, which has different methods of preparation, which is pan roast and boil cook respectively. I'm creating two objects, spicy and sweet, for these types that implements these methods. And then I'm having a eat function, which takes both of these types as a union. So we are doing a type guard with in operator, whether the method exists, and then calling delicious.pan roast. Now you notice that we are not doing a type guard explicitly for pongal type. Instead, we are using an else statement. TypeScript automatically understands that this implementation is for the type Pongal because it is under else. So when I call eat of sweet, I get the print, I get to print the log of Sakare Pongal, whatever this written here, rice and lentils with milk. Whereas when I call eat of spicy, I get this message of masala dosa. So if we use a return type, if we use a return inside a type card, then whatever is outside the if statement is considered for the other type. So we need not, when we are using return, we don't need to use even else. So basically TypeScript can type narrow after a type card if the type card has a return or any other terminal statement within its block. So no else required in this case. So in this example, we are saying two types, ragam and talam. So we are defining two objects, mohanam and rupakam, for the types ragam and talam respectively. So I have defined the functions learn Carnatic to take either of the type. So the if statement is the type guard of the type ragam as it checks for the method sing. Here it is returning a value in the type guard. So the return for type talam does not need an else here. So it will just return lesson.tab if it is of type talam. So far we have used the keyword type to define types. However, there is another way to define types. That is with the interface keyword. The syntaxes for type and interface are slightly different since interface does not require an equal sign. Before the typed object, functionally, both will enforce the type object at compile time when typing a variable. The biggest difference between interface and type is that interface can only be used to type objects, while type can be used to type objects, primitives, and anything. As a type, as you can see, type is more versatile and functional than interface. So why would we use interface? Sometimes we don't want a type that can do everything. We would like our types to be constrained, so we would more likely write consistent code. Since interface may only type objects, we'll use where the program needs many typed objects. So in this case, I'm typing it, the interface grade has the interface grade is being used by the by get marks here, and it provides the grade and the percentage here. The interface keyword in TypeScript is especially good for adding types to a class. Since interface is constrained to typed objects and using class is a way to program with objects, interface and class are a great match. TypeScript gives us the ability to apply a type to an class with the implements keyword. So here we have an interface guardian, which has a method broadcast. The class Galaxy Guardian implements guardian. So implements is the keyword here. So if you notice, it implements the method broadcast from the interface. So apart from that broadcast, you also see it has another method save planet. So when we create an instance of the class guardian1, we can call the method broadcast, and it would print I am Groot in this case. So implements an interface allows us to create types that match a variety of class patterns. So its interface is a good tool for using object-oriented programming. As our programs grow and become more complex, we will need to add more methods and properties to our objects to accommodate more features. In fact, we may need to add nested methods and properties. To type an object nested inside another object, we could write an interface like this. If you see in this example, the planet is nested under address, which is nested under home, which is nested under location, which is nested under profile. TypeScript allows us to infinitely nest objects so that we can describe data correctly. So what I have done here is created a class Galaxy Guardian that implements the interface Guardian with the nested variables. Then I'm creating an instance of the class and accessing the variable with dot operator. Say some guardian dot profile dot location dot home dot address dot planet. So it may seem a little overwhelming to have such a nested structure like this on the left side. So how can we do it better? So as we saw in the previous example, as we add more data, the interface may become so nested, it's hard for ourselves or other developers to read. So it's likely that we may want, and also in the case, some cases, we may just want a nested part of this type somewhere else in the code, and we would have to repeat it. So to solve this, TypeScript allows us to compose types. We can define multiple types and reference them inside other types. Here's the previous example, rewritten with individual types composed together, say interface, location, home. You have to read it from this below. So if you see, planet and city is part of the interface address, and address is a part of home interface, and then home is a part of location interface, and location is then here defined. So this is much more easier and neater to understand. In TypeScript, it's not always enough to be able to compose types together. Sometimes it is convenient to copy all the type members from one type into another type. We can do this with the extends keyword. Using extends can help us organize our code by abstracting out common type members into their own interface, then copying them into more specific types. Basically, in this example, student has all the properties of a child plus an additional method study. Then grade 4 is an object of the type interface student. This implements the method study as well as assigns name and age, which are required by the child interface. So this is an example of extending interfaces. When typing objects in TypeScript, sometimes it's not possible to know the property names of an object for an object. Like when we get back the information from some outside data source or API, we may not know the exact property name at compile time. But we may know what the data will look like in general, like the type. In that case, it's useful to write an object type that allows us to include a variable name for the property name. So this feature is called index signatures. So we see in this example, the interface edibles has a key name within square braces as edible : string. This is an index signature. This is what is an index signature. So which means that the key may not be of the name of edible. It may be any other name, but it will be of the type string. So this Edible is just for our reference. So in the next step, we are defining the object of the type interface edibles with different keys such as sweet, savory, snack, but all of them are of type string. But generally, the index signature accepts only string, number, or symbol as key type. If you try to use, for example, a union of string literals types as keys in an index signature, it would be an error, like it's shown in this example. So it will throw an error in index signature. Parameter type cannot be a literal type or generic type. Consider using a mapped object type instead. So a common scenario in programming is creating a function or class that can take in many arguments, some of which are required and some that are optional. Every interface within this lesson so far we have discussed assumes that every type member is required. However, TypeScript allows us to make some type members optional. So you take a look at this code. In this case, last name is optional in the interface profile. So I can call get profile just with the first name as Sadhguru and profession as Guru alone. And I can also call it with the last name, like Sachin Tendulkar, profession as cricketer. So optional type members in TypeScript basically allows us to create programs that don't require us to pass in every possible key value pair. So it makes our program more concise and easier to reason about. And I'm done. Thank you for providing me this opportunity to conduct this session. If you have any questions, you're welcome to ask. I will just stop my sharing.
Well, thanks for presenting that. That was really informative. I've been very curious about TypeScript, so it was cool to get a rundown on it.
Oh, great. I'm glad it's useful.
Now, are there a lot of so with TypeScript, are there extra like I know this was just an introduction and basically how to use the different types and all that, but does it also include like new functions and all that? Because I know that earlier you said that like
No, TypeScript is all about just types, and it's basically using JavaScript with types.
Oh,
So
okay.
this is all the topic that at least I know of TypeScript.
Okay, cool.
Okay. So I think if that's all, we can stop the recording. Yeah.